Hello, everyone. Welcome to our third in our ongoing series of free public webinars covering EPA's Clean Power Plan, which was released just 2 short weeks ago on August 3rd. My name is Sarah Jackson. I'm a Senior Associate at Synapse Energy Economics, and I'll be moderating today's discussion. I'm joined here in a hot conference room in Cambridge by Pat Knight, who's an Associate at Synapse, and Liz Stanton, who is one of our Principal Economists. Pat and Liz are 2 of the Synapsers who have been working tirelessly these past 2 weeks to review and digest the thousands of pages of policy and technical materials that make up the final Clean Power Plan. Some of you may also know them as the developers of our Clean Power Plan Planning Tool, CP3T tool, which is a free open source screening tool for modeling compliance with the Clean Power Plan and is available on our website. Today, Liz and Pat are going to present a deeper dive on 2 important elements of the Clean Power Plan that have changed fairly significantly since the rule was proposed last year. First, we'll hear from Pat about how EPA established the new Clean Power Plan targets, and then Liz will walk us through the 7 new compliance options for meeting those targets. First, just a couple of logistics. This webinar is being recorded and will be distributed with the slides to all of the attendees here. It'll also be available on our website. All of you are muted, so we can't hear you if you talk, which means if you want to ask us questions, you can send them to this email address here, webinar@synapseenergy.com. Liz and Pat will present for about 30 minutes, and then we'll turn to questions from all of you. I'll be monitoring those questions as they come in and pass them on to our presenters. We're going to do our best to answer as many questions as we can, but I suspect there are going to be a lot of questions today. And if for some reason we can't get to your question, please feel free to follow up with us after the webinar. If you're having any technical difficulties, if you can't hear us or see our slides, please use the chat feature in WebEx, and our expert WebEx support person will help you try to work through that problem. All right, well, let's see what makes the Clean Power Plan tick. Pat?
Sure. So thanks for that, Sarah. So just before I get into the actual content, I want to preempt this a little bit just to say that much of the material we're going to cover today is very technically complex. And because of the short amount of time that we do have, we're going to be simplifying some concepts, and in some cases we'll be skipping over text on the slides. That doesn't mean that the text isn't important. We're providing these slides as a resource to all of you, so the information will be there in the future. However, if you do have any questions about material that we skipped over or glossed over, please feel free to ask questions about that. So to get started, this is a really important concept. The new rule is not the proposed rule. So we're guessing a lot of people on this call have some experience with the building blocks and the approaches used by EPA in the proposed rule to set up the targets in the proposed rule. Not to say that knowledge will not be helpful here, but EPA has made many, many changes to their target setting. And even if the final state-by-state numbers look similar in some states, or even if you see similarly named pieces of this target formulation, please note that there are significant differences from the proposal. So with that disclaimer, let's move on to the compliance paths. And I'll be talking about these or teeing them up at the beginning just to give you all an idea of where we're going with the target setting that we'll be spending the bulk of this webinar on. So unlike in the proposed rule, in the final rule, there are 7 different compliance approaches. And states can choose from any one of these as a path towards Clean Power Plan compliance. So first off, I'll talk about the ones on the left-hand side. These are the paths that have to do with rate-based compliance. So the first path is what we at Synapse call R1, and this is a path in which states subscribe to the nationwide emission rates developed for 2 different kinds of technology. There's one for coal plants, or fossil steam plants as they're called, and one for NGCC plants. In the second path, EPA has calculated a state average for these rates. So states that choose this compliance path apply the same target to all of their units in their state, regardless of the type of technology that is going on at this plant. The third rate path is what I'll call the different CO2 emission rates. And under this path, states kind of make up their own rates that they then apply to all the different units in the state. And they can do that as long as the average of the rates that they apply equals the target set up in R2. So those are the rate-based paths. Now I'll talk about the 4 mass-based paths. So the first one is what we call M1, and this is a compliance path that's applied only to existing units. And under this approach, EPA has allocated each state some level of CO2 emissions that they can emit, and the states distribute those allowances to individual units in the states. And those units then become liable. They have to possess one of these emission allowances for every ton of CO2 emissions that they actually produce at the plant. Under M2, it's pretty similar, but this time EPA has developed a slightly different target that includes emissions from new plants added to meet electric load in different states. M3 and M4, I'll just describe really briefly here. Liz is going to touch on these much more later, but these are what's called state measure approaches. They look a lot like M1 and M2 in the sense that one addresses existing plants only and the other addresses existing and new plants. But the difference here is under M3 and M4, states are actually the liable entity. It's up to the state to create a set of strategies used for meeting clean power plan compliance. That might include an RPS, that might include an energy efficiency standard, it might also include distributing allowances like an M1 and M2. But in both these compliance approaches, it's up to the state, and the state is the liable entity. So with that primer on the different compliance paths that we'll be working towards, I'm going to spend the next couple minutes talking about target setting. So under the final rule, EPA follows this diagram that we've drawn up here for you. So just to give a general outline of it, EPA takes information about generation capacity and emissions in 2012, applies some adjustments to that data to get a baseline, and then applies a series of building blocks to figure out what the standard for emission rates will look like in the future under a set of assumptions. These emission rates then get translated into each one of the 7 targets that's used under each one of those 7 approaches that I just discussed. So first, I'll start off by talking about the baseline. So again, EPA starts with unit level 2012 data on generation capacity and emissions, and to turn it into the baseline, EPA adjusts for things like anomalous hydro generation. They adjust for significant unit outages in some cases, and they adjust for the inclusion of new under construction units. And these are just under construction units for coal and NGCCs. And basically, you can think of these as EPA listens to stakeholder comments during the time period between the proposed rule and the final rule, and incorporated these adjustments in their 2012 data in order to make a more illustrative year or applicable year to all future years. So after EPA has done that, it takes the generation capacity and emissions and sums them into 3 different interconnects. So here's a depiction of the 3 interconnects. We've got Eastern, Western, and Texas. And next, EPA goes into calculating their first step in the target setting process, which is calculating the baseline emission rates. And the emission rate calculation that you'll be seeing over and over again here is just pounds over megawatt hours. And it's really important to note that EPA, throughout this target setting at least, is always calculating 2 separate trajectories, one for fossil steam and one for NGCC. And it's going to be doing this for every single year during the compliance period, that's 2022 through 2030 inclusive, in the 3 different interconnects. So there's a lot of dimensions to keep in your head, and we'll try to keep reminding you of those as we're going through all of this. One thing that Liz just pointed out to me, I want to remind people that fossil steam is kind of a funny name at first, but you can think of this as being mostly coal. It does include some oil and gas generation emissions, but for the most part, it's coal generators. So after the baseline, EPA proceeds to building block 1. And building block 1 is all about heat rate improvements. Under this building block, EPA applies a number of heat rate improvements to just the coal plants in their baseline groups. And the heat rate improvement factor that gets applied depends on where that coal plant is located. EPA assumes that if the coal plant is in the eastern interconnect, coal plants can do more to improve their heat rate. And if it's in the west, for example, many coal plants are already quite efficient and they can't quite reach the same level of heat rate improvements. So with that building block, EPA returns to its two different categories of resources and figures out what the new achievable emission rate is. So you see here, the fossil steam emissions has gone down, or that's what's being represented by this diagram at least, as a result of heat rate improvements. The generation is staying the same. And for NGCC, nothing has changed. It's all baseline. Next, EPA moves, somewhat confusingly, into building block 3. And it's confusing because the blocks are out of step for some reason. But building block 3 is all about new renewable generation. Under this step, EPA has used modeling, it's used forecasts from NREL, and it's figured out an estimate of how many megawatt hours of renewables could be in place in each one of these 3 interconnects in the future between 2022 and 2030. EPA then takes the total number of renewables in each year in each interconnect and figures out what type of resources get displaced by this new generation. So the example that we're showing here is that in the eastern interconnect, 64% of the baseline generation is fossil steam, 36% of the baseline generation is NGCC. So therefore, for every 100 megawatt hours of new renewables, 64 megawatt hours of fossil steam gets replaced by renewables, and 36 megawatt hours of NGCC generation gets replaced by renewables. So again, EPA does this to every single interconnect and every single year and figures out what the new fossil steam average emission rate is. And it does this by figuring out what the generation for fossil steam has decreased to as a result of this new RE potential, and what the emissions in fossil steam has also decreased to as a result of the drop in generation rather. So really important to note here is that in almost every single one of these emission rate equations that we're going through is that the denominator megawatt hours are kept constant throughout. So to think of this another way, this denominator is going to stay constant in pretty much every one of these equations, and the emissions are going to go down, and that's going to result in an emissions rate that decreases over time. So the example that I was showing here was fossil steam, and this next one is just a very similar one for NGCC emission rates. Next is building block 2. So in building block 3, the last step, we looked at what happens when new renewable generation comes online and displaces fossil steam and NGCC generation. In building block 2, we're saying, well, what happens if generation at existing NGCCs increases and displaces existing fossil steam generation? So here, EPA is assuming that NGCC generation is ramping up to 75% over time. There's some restrictions there that we can get into if you're really interested. And they figure out how much fossil steam generation is displaced by this new NGCC generation. And that's the formula that we're showing down here. The elements are the fossil steam generation, which has gone down, the NGCC generation, which has replaced it, and the RE potential for fossil steam that was the same as in the last step. And again, the fossil steam emissions on the numerator has decreased, but there's been some increase from NGCC emissions, that incremental piece that we're counting towards fossil steam. So again, the denominator is staying the same, the numerator is decreasing. Over time, this emission rate goes down. And the last piece is NGCC. So here, what we're saying is this equation accounts for all NGCC generation and all NGCC emissions. So this is the only situation in which the denominator increases and the numerator also increases. And at first blush, this might seem like double counting or something like that. It certainly seemed that way to me. But as you look into the equations, it seems that EPA designed this in order for really two main reasons. The first is to ensure that NGCC displacement can be used as a strategy to decrease emissions from coal plants. And the second is to avoid an overly complicated accounting system under which EPA would have to, regulate the incremental generation separately from both fossil steam and the baseline NGCC. So those are the two building blocks, or those are the many building blocks, I suppose. Next, Liz is going to get into how the sequence of fossil steam and NGCC emission rates get calculated in each year. Again, if you have any questions, please send them to webinar@synapse-energy.com. and we'll answer them at the end.
Great, thanks, Pat. That was a really good summary, getting us to the point where we can talk about how the actual targets are made. And as Pat teed up back around slide 6, there are 7 different compliance paths, and each one of them has a set of targets that's associated with it. And that's in part what we're depicting here if you're looking at slide 25. And we started with the baseline data. We made these adjustments to it using the building blocks that Pat described. And from those ingredients of information, we can then calculate each of the targets that are necessary for these compliance paths. What you're seeing here in the schematic is that the targets are related to one another. So first, the R1 target is calculated, and R1 is the technology-specific rate-based target. From that target, those sets of targets, the R2 targets are calculated, and those are the state average rate-based. And from those, the mass targets are created. And so they're all interrelated. This is the sequence that you're seeing here. You can't get to the mass-based targets without first calculating the rate-based. You can't get to your state average rate-based without first calculating the state technology-specific. So let's start there. R1, the rate-based technology-specific targets. So these are 2 sets of targets, one for fossil steam, one for NGCC. And they're applied at the unit level. It is the units that have to comply with these targets. We're just going to look here on this slide at fossil steam, how the fossil steam targets are developed. The NGCC targets are exactly analogous, but for NGCC, completely parallel. So for the fossil steam, based on the building block calculations, the ingredients that we have are for the 3 different interconnects, Eastern, Western, and ERCOT, which is mostly Texas. We have a emissions rate for each of the 2 technologies, fossil steam shown here and NGCC, for each of the years in the compliance period from 2022 to 2030. You can see that in figure number 1, that those are depicted. What EPA does is it takes the least stringent of these targets for each year. It happens to be that is always the target developed from the data in the Eastern interconnect. The other 2 interconnects data then disappear, they're discarded, and we just focus on the least stringent. That means the highest emissions rate, the least stringent to comply with, and those are the targets for the entire United States moving forward. We take those least stringent emission rates developed in that way, and first there are some non-binding glide path goals. These are for states to use to make sure they're on target to get to the actual binding compliance goals. There are 3 of them for a few years each. States don't have to comply with these. They can make up their own compliance goals as long as the goals are consistent with complying with the actual binding requirements. In image 4 here, you see the actual binding requirements, and there are 2 for fossil steam units in R1. The first is that on average, during the 2022 to 2028 period, fossil steam units in states that are using the R1 compliance pathway must achieve this emissions rate. And if you look down to 5, you can see what the number actually is. It's 1,534 pounds per megawatt hour. That same emissions rate for the 2022 to 2029 period is applied to every single state that chooses R1. For 2030, the target is 1,305 for fossil steam. For every state that chooses R1, all of their fossil steam units must achieve that target. You can see here what the natural gas ones as well. We haven't done the graph for it, but for the interim goal period is 832 pounds per megawatt hour. For 2030 and after is 771. So for this R1 choice compliance path, the state, by taking that on, is making a requirement on each fossil unit that for the fossil steam units, mostly coal, they have one set of emission rates that they must achieve, and for the NGCCs, they have a different set that they must achieve. They can achieve these targets by purchasing offset credits. And that's more a discussion for a presentation about compliance, but just to be clear, these are the targets. There isn't just one way that you can hit those targets, even if you're using unit-specific ones. You can use a variety of ways to achieve the targets, including buying offsets. So on to R2, the rate-based state average targets, and you can see here that those are developed from the R1 targets. So for each state and year, what you do is to get your state average emissions rate, which are unique state to state, you take a weighted average of the technology-specific R2 target. And it's weighted by generation in the baseline year. And so in the baseline year, EPA has looked at, for that state, how much of that generation, what share was fossil steam, what share was NGCC. Those are used as weights on the technology-specific target, and from them you get your state average emission rate for the R2 target. Here's an example, just based on the real targets presented by EPA for 2030, Alabama. You can see that if it were using R1, then all of its fossil steam units would need to meet the 1,305 pounds per megawatt standard. All of its NGCC units would need to meet the 771 pounds per megawatt standard. It could also instead choose R2 to comply using the rate-based state average targets, and in that case, all of the fossil steam and NGCC units in Alabama would need to meet 1,018 pounds per megawatt hour standard. And that's going to be different state to state. And this is just summing that up. Again, that doesn't mean that each unit needs to achieve that target just through monitoring or through complying with its own generation and emissions. They can buy offsets in order to achieve the target that they're looking for. Following this diagram here, from the R2 state average rate-based targets, the R3 are also calculated. And R3, it's just down here on the bottom of this slide. It's just another variation on R2. For R2, each state has a state average target for all units, and that's applied to every unit in the state. For R3 instead, it's a little bit different. States can choose to give different targets to different units. They can make up a design of which units will have to meet which targets, and then the requirement on them is that on average for the state as a whole, they achieve the same state emission target as over in R2. So there isn't really another calculation here in target setting, but in compliance, the states would have to demonstrate that their plan for assigning targets to different units, different targets for different units, would in fact achieve the state average target. Okay. I'm going to move over into the mass-based targets. And again, looking at the diagram, the mass-based targets, starting with M1, are developed from the R2 targets. The R2 was the state average. You use that to get to your M1. just to look at this diagram for a second, you can see there's 4 different kinds of mass-based targets. There's really just 2. The M1 and M3 are the same as each other. They're identical. And the M2 and M4 are also identical. And we can talk in a moment about why those are different compliance pathways if their targets are actually identical. But we'll first introduce the M1 and M2. So the M1 is the mass-based target for existing units only. So if you were a state choosing this, you would be applying it to the total mass, the total tons of CO2 emissions emitted by your existing units, where existing is either having been in operation in 2012 or under construction as of 2014 is the under construction date. So when we head over here into the mass base, it becomes a little bit more difficult to describe. It gets more complicated as you move out through the diagram. So we were doing okay in the building blocks and maybe through R1. Hopefully R2 is pretty easy. It's just a weighted average of R1. When we head out into the M's, yeah, I have to confess, it gets more complicated. We're going to give you the short version. So here's the short version. Mass-based targets for existing units are calculated as the highest CO2 emissions in tons possible while complying with the R2 rate-based target. That's what EPA is doing. They're figuring that out, that if a state picked R2 as its compliance path, what's the most that it could possibly manage to emit and still be in compliance? They take that number and they make it the ton-based limit. And that's the shortest version of it. A little bit about how they get there. The way that they're figuring this out is on the basis of what is called the unneeded renewable. And the idea of the unneeded renewables is that way back in building block 2, EPA calculated the total renewable potential for the entire United States. They did it interconnect by interconnect. Building block 3, sorry. Yes, Pat just told me it was building block 3. I keep getting them confused because they're in the wrong order. Back in building block 3, and I think we're wrong here on the slide too, so we'll have to fix that before we put it up online. They calculated the renewable potential for the United States, but then that was based on the renewable potential in the 3 interconnects, but then they picked the least stringent interconnect, the eastern one, and had they instead picked one of the other 2 interconnects, more of those renewables would have been needed in order to achieve those targets, but they didn't. They picked the least stringent one, and so there are all of these unneeded renewables. Renewables, what a potential for them has been established, but they're not actually needed to meet that least stringent of the 3 interconnects target that was chosen. So EPA figures out how many megawatt hours are there of unneeded renewables, and then they allocate them to the states. And they're allocated to the states in proportion to their baseline fossil generation that's covered under the rule. And the thought experiment they're doing is that if those unneeded renewables were out there available as what we've been calling ERCs, which are emission rate credits, the emission rate credits, that's what I was saying as offsets before. They're basically offset credits. If those were used as ERCs, as offset credits, then how much could the fossil and NGCC units raise their emissions while still meeting their targets? So if they were purchasing those ERCs as offsets, they could raise their emissions and still meet their targets. EPA figures out just how much they could be raised while using the unneeded renewables to meet their targets, and that's the answer to how much could you possibly emit while still complying with the R2 rate-based target. A couple assumptions in here. One is that the ERCs that they're using for this calculation are just based on the renewable, and so when we get around to talking more about compliance in the future, that may look a little bit different. So that's the basic process for how to do it. The way that they're doing it is very complicated. It involves some complex modeling to get to this answer. So for M1 and M2, for M1, this process is used to get to a ton target for just the existing units. M2, which I'll talk about in a second, goes through a similar process to tell us what are the tons possible based on the R2 rate for both existing and new units combined. And I want to keep us more or less to our half an hour of talking, so I'm going to move quickly through the last part here. Let's talk about M2. So this is mass-based existing and new unit targets. Here a state is choosing mass-based, a ton-based target, and to combine its existing and new units. If it were choosing one, it would be complying with regulations about new units under a different rule separately, in a separate bucket, if you will. In the M2 choice, it takes existing and new units, throws them in both into the same bucket, and just complies with one rule about the two of them. And the way that EPA is making this calculation is they start with the M2 targets, and to it they add what is called the new source complement. And this is done with calculations for each interconnect that's made then state-specific. The idea of it is that they're figuring out what's the expected growth in electric sales based on forecasts from EIA, and given that growth, how much more generation do we need to emit, how much more generation do we need to meet it beyond what is being generated today? So they figure out this total extra, this additional sales in the future, and from it they subtract a couple of things. They subtract generation from units that were under construction in 2012 through 2014. They weren't running in the baseline. We want to make sure that before we calculate our new source complement that we subtract that out. We also subtract out the generation from the so-called unneeded renewables, those extra renewables that weren't needed for compliance. Subtract that out too. If those were actually used as ERCs, they must have been actual generation and should be subtracted from those new sales. So the leftover part is the new source complement. It's the part that must be provided by some kind of new generation if we're going to meet those increased sales. Of course, this is putting energy efficiency to one side. That's not part of the target setting discussion, although it's certainly part of compliance, a compliance discussion. They take the new source complement piece, they multiply it by the actual target on that other rule, which is called 111B, the rule that's for new NGCs, and that tonnage is added to the tons for the M1 target, and there you go. You've achieved your M2 target. So I said it was complicated. That's about how it works. Very briefly on M3 and M4, the idea with these is they're actually the same targets as M1 and M2 respectively. One's about existing, one's about existing plus new. The difference is in how the state complies with that, how the state also sort of demonstrates to EPA that it's able to comply, that it's going to comply in the future. M1 and M2 are more directed at being unit-specific, at being rules that, or requirements placed on units. M3 and M4 are what are called state measures, and so here the states can demonstrate that they have a variety of different policies that will have the effect of reducing their emissions to this level. So it's a different way of demonstrating to EPA that you have the right goals and programs in place in order to meet your objectives. So I think that got us through the end of it. I think Sarah's going to say a few things in general, and then we'll move over to questions.
Yeah, that's right. Thanks, you guys. That was, I think, a really great presentation for a really complicated couple of topics. We'll turn to questions in just a second. Please send them in to webinar@synapse-energy.com. We've had a few questions come in, but there's still room for more here. The first thing I want to say is just that we at Synapse are in the process of developing our modeling capabilities for evaluating the final rule. That includes upgrading a lot of our existing tools to account for the requirements in the final rule. this slide here shows you a number of our modeling capabilities, and we call this our planning toolkit. So look for that on our website. And then we also have a number of other resources here. There's actually a link here to the toolkit. At the top, we also have links to our past webinars. We've had 2 so far on the Clean Power Plan. And so you can look at those and you can watch the webinars themselves and get a copy of the slides. And we've also done a lot of work for various clients on analyzing the proposed rules. You can find those reports here. And we've also worked on crafting a number of blog posts related to the final Clean Power Plan. And so you can get a lot of good information at through those blogs. We are doing even more webinars, so stay tuned for those. Next week, on August 26th, we'll be talking about renewables integration and the Clean Power Plan. So that should be a really interesting topic. That's a big part of this. And there will be additional webinars after that, so please stay tuned. I think now is time to turn to questions, and since I'm the moderator, I get to start off by asking just a quick clarifying question to Pat. You had mentioned when you were talking about how building block 3 is calculated, we had a question about whether they use generation, so megawatt hours, or capacity to figure out what that target is.
Sure. So basically the way, as I understand it, the numbers are calculated. So the final numbers that actually get used in the building blocks are in megawatt hours. So we're talking about megawatt hours of new renewables that can replace the megawatt hours of existing fossil steam and NGCC generation. As far as how EPA got to those numbers, what they looked at was a number of NREL studies, so that's the National Lab studies on renewable potential, and they modeled that using EPA's IPM model. So you can take a look at the Clean Power Plan technical support documents. There's a big section in there about all the different IPM runs, and you can see for yourself the assumptions that they used for calculating the renewable potential in each one of the interconnects in each one of the future years.
And then one just final clarifying question on that is the basis, when we talked about the baseline, that's 2012 generation data. That's right?
Yep.
So I think the question was whether it's based on 2012 capacity. A little more simple than what you were saying, whether it's based on 2012 capacity or 2012 generation.
Sure.
And it's 2012 generation from all the existing units.
Right. So just to stay on this topic for just a second, so in the baseline, EPA is looking at the 2012 generation and the 2012 emissions. And those are the two things that really matter. EPA also figures out what the 2012 capacity is, and it uses that to figure out what the incremental or possible generation from the existing NGCCs would be in the future if they increase up to 75% capacity factor. Can't do that without knowing the capacity. With regards to the renewables, just to clarify, what EPA is talking about here is all about generation from new renewables. So existing renewables are not part of this target setting at all.
Thank you. So pretty much everything that we've said about renewables today, we didn't say it at the time. We meant new renewables, incremental renewables from the baseline.
Great. Okay, another question was, I didn't hear you say anything about peaker, combustion turbine type units. Are those now covered at all in this rule?
Sure, so that's a really good question, and it comes down to a lot of basically the filter that EPA applies to its universe of units. So EPA starts off with every single unit in the country. There's hydro units, there's nuclear units, there's wind units, there's fossil steam or coal or oil and gas, and NGCC units. And they apply a set of filters based on how big the units are, what their heat rates are, whether they're part of a plant that has other units. And in some cases, the units that make it through that filter to actually be affected by the Clean Power Plan do include oil and gas steam peakers. And those are what gets included under that fossil steam category. So coal and oil and gas steam peakers. If your question is more about like maybe traditional like gas turbine peakers, in general, no, those are not part of the Clean Power Plan at all.
Okay. Thank you. So we had a question, I think this could go to either of you, but Liz, you were presenting on R1. And you explained to us that the EPA chose the least stringent of the 3 interconnect, what do we call that, rate trajectories. And the question was whether that means that units in other areas now have an easier time, in the West and in ERCOT, do they now have an easier time complying because the nationwide standard is based on that less stringent, for them, Eastern interconnect number?
That's a tricky question. That might be the case for some units. I think you'd have to answer to be really accurate about how you answered it. You'd have to sort of answer on a unit-by-unit basis. Certainly, in each of those interconnects, EPA was using actual baseline data from units to get to the targets, and the targets that they found were more stringent. Of course, the targets also included using things that were not unit-specific, like the RE potential, right? So the fact that an interconnect has more RE potential doesn't have anything to do with how easy or hard it is for a unit to change its emissions, right? So I wouldn't be comfortable making that as a sweeping statement about the units. And you know, another thing that's true about the fact that they are using the RE potential to figure out those different trajectories for the different interconnects is that it's certainly potentially possible that there could be purchases of those offsets, those ERCs, or in the mass-based compliance of other sort of ton certificates across interconnects. So the RE potential in one interconnect could actually be tapped in another interconnect, depending on the choices that states make about their compliance paths.
And just to add on to that, another detail is, if you'll think back to that, I think it was slide number 26, so where there was the 4 different charts and then the set of final targets down at the bottom for fossil steam. And I think this may be where your question came from about stringency. Part of the reason that the Western and ERCOT trajectories are so much lower than the Eastern is because through the target calculations, EPA figured out that there was more displaceable natural gas in these other 2 regions. So again, these charts are all about fossil steam. If you looked at the NGCC charts, they'd be a bit different. And in fact, in some years, the limiting interconnect, as EPA calls it, isn't Eastern at all. It's Texas or Western. So it's important to sort of keep things in perspective and think about exactly what's lowering the trajectory, whether it is in fact renewables, whether it's the heat rate improvement, or whether it's the natural gas redispatch.
We've actually had a couple questions. Thanks for that, guys. We've had a couple questions asking for clarification. I know we didn't go into ERCs much in this presentation, and that, I think, will be for a future webinar that discusses all the compliance options for states demonstrating compliance. But it looks like we have a little confusion about whether ERCs can be used by mass-based states and vice versa, whether mass-based states can use ERCs to comply.
I'm going to give the simple answer, and then Pat can chime in with the more detailed technical answer about this. Mostly no. There's a couple of exceptions where yes, but mostly no. And so the thing to think about is that I have a slide showing where the different compliance paths, the 7 different compliance paths are showing. The compliance path that you choose determines who you can trade with. And there are different rules about each one, but it's another thing about these compliance paths that depending on which one you pick, it creates a set of other states that you may trade with. And so there are limitations on trading.
Yeah, I think that pretty much gets at everything. There's a couple of weird little footnotes about this. If you have a renewable generator, specifically a renewable generator that's located in the mass-based state, but is electrically connected to a rate-based state, and you can prove that that renewable generator is displacing fossil emissions in that rate-based state, then that renewable generator basically becomes attached to that rate-based state and can start producing ERCs. But otherwise, as far as I can remember off the top of my head, there are no other, I don't want to use the word allowances because that has double meaning, exceptions for enabling trading between rate and mass-based states.
So an example of that kind of proof would be having a power purchase agreement or something along those lines.
Right.
Great. Thank you. We have a lot of great questions here. So this one has to do with, we heard when the rule was released that we'll be getting this 34% reduction from 2005. The question is whether that, I know that that is a complicated calculation that EPA did, but when EPA is thinking about these targets and what they're going to achieve with these targets, are they looking at just existing units without considering demand growth?
So a couple things. When you're talking about the difference from 2005, then that's based on EPA's IPM modeling. And so that's a complicated model that's going out into future years, and it's looking at all of the different wrinkles in it, including change in demand over time. And it's from the results of that modeling that they're then saying, oh, in 2030, the difference from 2005 actual emissions is this. Is that the whole answer to your question? There was a part two.
Well, it is, and I think maybe I made it more complicated than it had to be. I think that the idea is when EPA is calculating the targets that Pat walked us through, how do they account for load growth? And I think that the answer may be, at least in part, with the new source complement that Liz mentioned in the compliance options. So I don't know if you guys can elucidate that a little bit, or if it's something that needs to be for a later, more in-depth webinar on.
No, that's a really key part. So you might remember back to throughout the webinar when I kept saying the denominator in every single one of these equations is the same. It's the same, it's the same, it's the same. And then I got to the end and said, oh, but wait, this one's a little bit different. Because that last, in that last step, generation has actually increased. Overall, just within the building block steps, you actually do result in, you do produce increased generation. And part of that goes to meeting future load. But the other part of it is what that new source complement is meant to cover. So basically, the target setting is set up to allow for the fact that in the future, some future load might be met from existing units, increasing their power, and some of that future load might be met from new units getting built.
Okay, thank you. So we had, I think you guys may have been anticipating this question, but people were wondering what happened to nuclear and energy efficiency in the calculation of the targets. Can we talk about each of those?
So there are changes. I mean, that's where we started out. The new rule is not the proposed rule, and this is the rule. So for nuclear, yes, it's completely different than how it was treated in the proposed rule. It's just not being considered here in target setting. And that's the important thing to remember with a lot of these kind of questions is that we're talking about target setting here. The answer is different for compliance. And we, in our discussions about the proposed and final rule, have often set up the idea of there being 3 moments in the Clean Power Plan. And the first of those moments is this, what we're talking about today is target setting. The second is states demonstrating how they're going to comply to EPA. And the third is actual compliance in the compliance years. Those 3 things are important to keep in mind and to differentiate as you're talking about Clean Power Plan, because the answers are different depending on which moment you're in. And you can't just talk about a Clean Power Plan emissions rate. We need to know, are we talking about the target rate, the rate described by in a compliance plan, the actual compliance rate? They're different. So for nuclear, nuclear energy is certainly in and can be involved in moments 2 and 3, that's compliance plans and actual compliance. However, it's not taken into consideration when the targets are set. I think you could say pretty much the same. I could have answered that both for nuclear and energy efficiency. So everything I just said, also for energy efficiency. Pat, did you want to say something?
Yeah, but I don't want to dive too much into this because a lot of this is just really totally unknown information, at least to me. A lot of this rolls back to the EPA's idea of what they can, what would be legally enforceable under the Clean Power Plan. And I don't want to get too much into that because I'm sure there are lawyers out there that can describe this much better than me. But basically, you can separate it as the targets and the target steps and the building blocks that EPA used here were the ones that they considered to be most legally defensible. And building blocks that were not included in the final rule, like energy efficiency or nuclear, have been taken out, most likely for those exact same reasons.
Okay, thank you. We have had a couple people ask for clarification on the concept of the unneeded renewables and how they're parsed out. It's essentially, I think that's a strange thing that EPA did. Can you explain that again, just make sure we understand?
I can try. I think I've kind of gotten used to the idea and it's started to make sense in my head. So let's imagine that EPA had arranged the rule differently and had enforced different targets by interconnect instead of one set of targets for the United States as a whole. In that case, where are my interconnect pictures? Am I going the right way? So in that case, looking at number 1 here, this top line would represent the targets that units in the eastern interconnect were trying to meet, and the other 2 lines for the other 2 interconnects. If that had happened, units in those other interconnects would have needed all of the renewables that had been used to calculate these targets in order to comply. So back in building block 3, which comes before building block 1, a whole bunch of renewables were needed in order to get to these targets. So if you use these targets, the renewables are needed in order to achieve them. However, we're not using those targets. Everybody's using the eastern target for the entire United States. The western and ERCOT units aren't in need of those renewables in order to achieve these lower targets. It's in that sense that they're unneeded. They're unneeded to meet those targets that are not in effect. Does that help at all?
So they're extra renewable, it's extra renewable potential that they could use, but that they don't need to meet the target.
Exactly, yes, under the rate base, yes. Mm-hmm.
So to give an example of it, imagine you have a situation where a state has, or a unit has many renewables that are producing credits that it can take advantage of. It adds all those credits into its denominator, and it achieves the technology-specific standard that EPA set out for that particular resource type. So let's say it's fossil steam unit. But what happens if there's so many renewables that fossil steam unit could just buy up all of those ERC, those credits? What could end up happening is that could actually produce a lot more generation and a lot more emissions and still meet the exact same standard rate. So that's what's happening in a mass-based target. EPA is trying to account for the fact that you could have many, many more renewables than is allowed under this least stringent category, and that these fossil units could produce much more generation and much more CO2 because there are all those extra credits to buy. And what EPA is doing is it's setting the mass-based limit at the upper end of that. That's the ceiling.
So it's in this sense that it's been said, tongue-in-cheek, that renewables and coal can be friends. That the more renewables that we have, the more coal emissions that you can have and still stay to the same total emissions. So that may or may not be helpful. I think that, you know, if you think about this as kind of figuring it out for the U.S. as a whole, as if the whole country were one state. It could help to understand what's going on better. Just think about the entire U.S. And that to meet the targets, you don't actually need all of those renewables. There's a limiting factor here, though, because the limitation is how much generation we need year to year. And so you can't have more and more and more and more renewables without them displacing something. So it is a limitation to the idea that the more renewables you add, the more coal you could add, and you can keep adding them. And unless we're going to start exporting to somebody, then you can't just keep adding both of them and keeping your emissions rate equal. So.
Right. And I think as you guys explained, as Pat explained during the building block 2, EPA now incorporates the displacement of those resources in when they add in the new renewable.
Exactly, which wasn't the case back in the proposal.
So that's a big change.
Yeah.
Okay. We have time for about one more question. I have a lot of them. How do I think actually? So one question that people had to do. I think there's still a little bit of confusion around what the M3 and M4, maybe because it was towards the end. So do you think that you could maybe explain a little bit more about those, I think EPA called them state measures plans for mass-based compliance?
This one?
Sure. So EPA calls them state measures. I find it helpful to think about these as sort of portfolios of strategies. So let's contrast M1 and M3. So under M1, EPA has said every state has some cap on the amount of emissions that the generators in that state can produce. So let's just say the number is 1,000. You're California, your number is 1,000. Under M1, that state takes those 1,000 allowances and distributes it somehow to all of the units in the state. And it probably does that through an auction that may or may not look an awful lot like the Reggie program that we know today. Reggie is, of course, the Regional Greenhouse Gas Initiative. That is actually more or less the basis for this existing and new, that's the M1 and M2 steps, or pathways. So getting back to M3 and M4, so under M1, what's happened is the states have distributed the allowances, and individual units are now the liable entities, and they have to prove, if they're going to emit a ton of CO2, that they possess an allowance, they paid for an allowance that allows them to do that. Under M3 and M4, it's totally different, except for the target is the same. So here, a state says, thanks EPA for the target, we got you. We're going to use our own system to figure out how to reduce emissions to that target cap that you gave us. Maybe we'll do some allowance thing. That's a great idea. Yeah, we'll keep that in our portfolio. But hey, we've also got this great RPS that we've got a lot of time and investment on, and we want to make sure that gets counted as a way of reducing emissions in the future. Maybe that state also wants to do an energy efficiency standard, and there's all kinds of other things that they could do. And the important distinction here is that under these two approaches, M3 and M4, it's the state that's the liable entity. It's the state that's now responsible for making sure that it's meeting the emission caps. Back in M1 and M2, yeah, the state got handed the allowances, but then it distributed them, and it's the units that are responsible for actually making sure that their emissions are below a certain ceiling. In M3 and M4, it's the states that are ultimately responsible.
I just want to clarify one point. I know we're out of time. Quick clarification. So the relationship between Reggie and M1 and M2. So what I would say about that is that the existing program, Reggie, in the Northeast states is essentially one way that you could do exactly what's being asked of you in M2, because it includes both existing and new. You could imagine a Reggie that was just about existing. That's not what the current Reggie is. It's about any unit. There could be other ways to organize M2 that work exactly like Reggie, pretty close, but Reggie would be one way to do M2.
Okay, great. Thank you both. We had a lot of good questions, and I'm sorry if we didn't get to all of them. but please look for our information, and we'll be sending out the slides.
Yeah, sorry, I didn't mean to
telling me.
No, if you have any more questions, please continue to send them. Yeah, we're going to be looking at this email account webinar at synapse-energy.com, and we'll be answering any questions that we didn't get to yet, and any more that come in between now and the next webinar.
So what I would suggest is that if you have a question that didn't get answered, to go ahead and send that again. You can send it to webinar or to me or to Pat. There are some like that, but just there have been a lot of questions that kind of overlap, so it can be hard for us to tell if we've answered it or haven't answered it at this point. So go ahead and send it again, and then we'll know that you're still looking for an answer.
All right. Thanks very much for joining us.